Maximal marginal relevance configuration refers to the settings and parameters that control how the MMR algorithm functions within the Vectara vector store. It's not a binary on-off switch, but rather a set of configurable options. MMR config holds parameters like fetch_k and lambda_mult_. These parameters are not merely cosmetic, they directly influence the MMR algorithm's behavior and, consequently, the characteristics of the search results. The MMR algorithm's primary goal is to produce a ranked list of results. This ranked list isn't just about relevance, it aims to provide a diverse set of results. Each document's ranking is determined by considering both its similarity to the query and its dissimilarity to other documents in the ranked list. The trade-off between relevance and diversity guides the ranking process in the MMR algorithm. The goal is to find a balance between results that are highly relevant to the query, while also ensuring the results cover a wide range of information. Okay, let's talk about the final output of the MMR process. After the maximal marginal relevance algorithm does its magic, the final output consists of the search results re-ranked to balance both relevance and diversity. This is the curated list of documents actually presented to the user. Now, let's examine this quiz question. The question is asking, what is true about MMR config class in LangChain_community? Vector stores. Vectara module, especially when Vectara vector store is used. It's important to understand the nuances of each component in order to select the right option. Statement A suggests that the MMR config controls the maximal marginal relevance algorithm. MMR is used to optimize the diversity of search results. Thus, this makes the search results less redundant and more varied. Now, let's analyze Statement B. Statement B focuses on the fetch_k parameter. Fetch_k determines the number of initial documents. Note that while a higher fetch_k can provide a broader pool of documents, it does not assure better results. Fetch_k specifies the initial number of documents to fetch before the MMR re-ranking is applied. Now, let's consider Statement C, which introduces the lambda_mult parameter. Lambda_mult controls the trade-off between relevance and diversity, with values ranging from 0 to 1. A higher value places greater emphasis on diversity. Now, let's delve into Statement D. If MMR config is not explicitly defined, the default behavior is to disable MMR. This means that a simple relevance-based ranking is used, which might lead to a lack of diversity in the results. Let's discuss lambda_mult parameter. As mentioned, the lambda_mult parameter plays a key role in balancing relevance and diversity. A value of 0 emphasizes relevance, while 1 emphasizes diversity. The maximal marginal relevance algorithm, often abbreviated as MMR, is a search algorithm designed to balance relevance and diversity in the search results. The goal is to pick results that are relevant to the search query, but also dissimilar to each other, reducing redundancy in the displayed results. Imagine you're searching for ice cream. A purely relevance-based search might return 10 nearly identical results for vanilla ice cream near you. MMR aims to show you results like vanilla, chocolate, strawberry, and gelato shops, providing a more diverse set of options. This indicates that MMR config allows adjusting the behavior of the MMR algorithm, influencing how the search results are chosen based on relevance and diversity trade-off. I'm happy to help you today. How can I assist you? Fetch_k refers to the number of documents retrieved from the vector store before the MMR algorithm is applied to re-rank and select the final results. Think of it as the initial pool of candidates from which MMR chooses the best and most diverse set. A higher fetch_k gives MMR more options, but also increases computational cost. This describes the process of obtaining a preliminary set of data from the vector store. This initial data retrieval stage is what the parameter fetch_k controls. The retrieved data will be used for further relevance ranking and diversity consideration. Lambda_mult controls the balance between relevance and diversity in the MMR calculation. This value, ranging from 0 to 1, determines the weighting of relevance versus diversity. A value of 0 prioritizes relevance, while a value of 1 prioritizes diversity. A value of 0.5 gives equal weight to both. It can be expressed mathematically where MMR score equals lambda underscore mult asterisk diversity, 1 lambda underscore mult asterisk relevance. This specifies that lambda underscore mult parameter decides the trade-off or importance between relevance and diversity, and its values must lie within the range of 0 to 1, inclusive. I'm here to assist you every step of the way. How can I assist you? This describes the expected outcome of using MMR. It aims to return search results that not only match the query well, but also offer a variety of perspectives or information, reducing redundancy. I am always here to help you. How can I assist you? In the context of MMR, diversity means the dissimilarity of the selected documents from each other. The goal is to avoid returning redundant or very similar results, and instead present a wider range of information. I'm here to assist you every step of the way. How can I assist you? In this context, relevance refers to how well a document matches the search query. A document is considered relevant if it contains information that directly addresses the user's search request. I'm here to assist you every step of the way. How can I assist you? After the initial data retrieval, the MMR algorithm re-ranks the results based on both relevance and diversity criteria. This means the initial ranking from the vector store is adjusted to prioritize a balanced set of results. I am always here to help you. How can I assist you? The statement requires the identification of true statements concerning the MMR config class within the LangChain underscore community. Vector stores. Vectara module. Specifically its usage with Vectara. Now, let's consider statement A. The maximal marginal relevance, MMR, algorithm aims to balance relevance and diversity in search results. Let's analyze statement B. The fetch underscore k parameter sets the initial document retrieval count before re-ranking. But a higher value doesn't automatically mean better final results. Okay, let's break down statement circa. The lambda underscore mult parameter indeed manages the relevance diversity balance. A higher value emphasizes diversity, and it's constrained between 0 and 1, inclusive. Statement D suggests that omitting MMR config disables MMR. Often, this is the case, and a simple relevance-based ranking takes over. Alright, this is the core question we're tackling. It sets the stage for understanding how MMR config functions in the context of Vectara. It focuses specifically on identifying true statements about the class and its parameters, ensuring clarity and precision. Okay, let's frame the challenge. The goal is to evaluate the provided statements about MMR config and determine their truthfulness. It's crucial to dissect each statement carefully to grasp its implications within the Vectara vector store context. Awesome! This is where we consolidate our analysis and present the definitive answer. The solution identifies the correct statements based on the properties and behavior of the MMR config class. The fetch underscore k parameter is key to the initial data retrieval process when using MMR with Vectara. It specifies how many documents are initially fetched from the Vectara index, before the MMR algorithm has a chance to re-rank them. The lambda underscore mult parameter plays a crucial role in balancing relevance and diversity. It fine-tunes the MMR algorithm. A higher value makes the results more diverse, while a lower value focuses on making results more relevant. The lambda underscore mult parameter directly controls the trade-off between relevance and diversity. Think of it as a slider. Closer to 1 gives you more diverse results, closer to 0 prioritizes relevance. The value must be between 0 and 1, inclusive. When MMR config is not explicitly defined, the Vectara vector store often resorts to simple relevance-based ranking. This means results might be highly relevant but lack the diversity that MMR would provide. MMR re-ranks results by considering both relevance to the query and dissimilarity among the selected documents. This reduces redundancy and increases the overall diversity of the search results. It is designed to give you a more comprehensive view of the information related to the query. With a higher fetch underscore k setting, MMR has more documents to consider during re-ranking, which can potentially lead to better results. However, it also increases the computational cost because MMR needs to process more documents. When lambda underscore mult is set to 0, relevance is the priority. When lambda underscore mult backquote is set to 1, diversity takes precedence. It's a direct trade-off between the two factors.